The dinosaur-killing asteroid triggered a huge tsunami. What do you know about the dinosaur-killing asteroid that triggered a huge tsunami? If you haven't heard about it, well then this is the best place to be. Hello everybody, and welcome to Discovery Scene. In today's video, as you know, we will be discussing this asteroid which triggered a huge tsunami. So do you want to know more about events like this? Well, make sure to subscribe to our channel to unveil all of those shocking secrets. A 10-kilometer asteroid struck the Earth 66 million years ago, causing the demise of the dinosaurs. According to recent research, the Chicxulub impact also produced an enormous earthquake that shook the Earth for several weeks to months after the collision. This mega earthquake is predicted to have released 1,023 joules of energy, which is nearly 50 times more energy than the magnitude 9.1 Sumatra earthquake in 2004. In order to supplement his earlier work in Colombia and Mexico documenting evidence of the catastrophic impact, Bermudez traveled to the outcrops of the infamous Cretaceous-Paleogene or KPG mass extinction event boundary in Texas, Alabama, and Mississippi earlier this year with funding from GSA Graduate Student Research grant. The study represents the first global simulation of the Chicxulub impact tsunami to be represented in a peer-reviewed scientific journal, and it is due for online publication in the journal AGU Advances on October 4th. Additionally, researchers examined the geological history at more than 100 locations across the globe and discovered proof that their models' projections regarding the tsunami's path and force are accurate. The analysis of the geological record concentrated on border sections, marine sediments laid down immediately before or immediately after the asteroid impact, and the ensuing KPG mass extinction, which brought an end to the Cretaceous period. The range began the project as an undergraduate in Arbik's lab at the Department of Earth and Environmental Sciences. The distribution of the erosion and hiatuses that we observed in the uppermost Cretaceous marine sediments is consistent with our model results, which give us more confidence in the model predictions, said Range. The December 2004 Indian Ocean earthquake tsunami, which killed more than 230,000 people and is one of the greatest tsunamis in recorded history, had an initial energy that was up to 30,000 times greater, according to the study's authors. According to the team's models, the impact tsunami mostly spread east and northeast into the North Atlantic Ocean and southwest through the Central American Seaway, which once divided North America and South America, into the South Pacific Ocean. Underwater current velocities in those basins and certain nearby regions probably exceeded 20 centimeters per second or 0.4 miles per hour, a velocity powerful enough to destroy fine-grained sediments on the sea floor. The team's modelling showed that the strongest tsunami effects were mainly avoided in the South Atlantic, North Pacific, Indian Ocean, and the area that is now the Mediterranean. The modelled current velocity there was probably below the 20 centimeters per second cutoff. On Gorgonilla Island in Colombia, Bermudez discovered spheroidal deposits in 2014 while conducting fieldwork there. These deposits are layers of sediment containing small glass beads as large as 1.1 millimeters, and shards are known as tektites and microtektites that have been ejected into the atmosphere during the asteroid impact. These glass beads were created when the impact's heat and pressure melted and dispersed the Earth's crust, ejecting tiny, melted blobs into the atmosphere, which later fell back to the surface as glass due to gravity. EMS examined 165 published records of maritime boundary sections for the assessment of the geological record and was able to extract useful information from 120 of them. The majority of sediments came from the cores that were taken during research initiatives involving ocean drilling. The South Pacific and North Atlantic had the fewest locations with uninterrupted, complete KPG border deposits. In contrast, the South Atlantic and the North Pacific, the Indian Ocean, and the Mediterranean were the most complete KPG boundary sections were discovered. According to Arbik, a professor of Earth and Environmental Sciences who directed the experiment, we found corroboration in the geological record for the predicted areas of maximal impact in the open ocean. The geological findings definitely strengthen the paper. The KPG border outcrops on the eastern branches of New Zealand's North and Southern Islands, which are more than 12,000 kilometers or 7,500 miles from the Yucatan impact site, are particularly relevant, according to the authors. Initially, it was believed that the extremely disrupted and unfinished New Zealand sediments known as Olistosome deposits were the product of nearby tectonic activity. The led research team, however, has a different theory about the origin of the deposits because of their age and their proximity to the tsunami's predicted route after the Chicxulub hit. We feel these deposits are recording the effects of the impact tsunami, and this is perhaps the most telling confirmation of the global significance of this event, Range said. The study's modelling component employed a two-stage approach. First, the chaotic first 10 minutes of the event, which included the impact, crater creation, and start of the tsunami, were reproduced by a sizable computer program known as Hydrocode. Brandon Johnson, a co-author from Purdue University, carried out the research. The researchers created a model of an asteroid with a diameter of 14 kilometers or 8.7 miles and a speed of 12 kilometers per second based on the results of earlier studies, which is roughly or approximately 27,000 miles per hour. It struck a granitic crust covered in thick sediments and shallow ocean waters, ejecting copious clouds of soot and dust into the atmosphere and creating a crater that was about 100 kilometers or 62 miles across. A wall of water was forced outwards from the impact site 2.5 minutes after the asteroid hit, briefly creating a 4.5 kilometer high or 2.8 mile high wave that dissipated when the ejector plummeted back to Earth. According to the simulation, a 1.5 kilometer high or 0.93 mile high tsunami wave that was ring-shaped and was spreading outwards started sweeping across the oceans in all directions 10 minutes after the projectile hit the Yucatan, 220 kilometers or 137 miles from the place of the impact. At the 10-minute mark, Johnson's ISAIL hydrocode simulation data was sent into the MOM6 and MOST tsunami propagation models at the 10-minute mark to trace the enormous waves across the ocean. Deep ocean tsunamis have been modeled using the MOM6, and the NOAA Tsunami Warning Centers employ the MOST model to forecast tsunamis operationally. But according to their calculations, the Gulf of Mexico would have seen open ocean waves that were over 10 meters or 32.8 feet high when the tsunami approached the North Atlantic coastline and portions of the Pacific coast of South America. Wave heights would have substantially increased due to a shoaling phenomenon as the tsunami approached certain shorelines and came into contact with shallow bottom waters. Current speeds would have exceeded the 20 mm per second limit for most coastal regions across the world. According to the study's authors, depending on the geometries of the coast and the advancing waves, most coastal regions would have inundated and eroded to some extent. Any historically documented tsunamis pale in comparison with their global impact. According to Arbic, the scope of the coastal inundation worldwide will be modeled in a subsequent study. Vasily Titov, a co-author of the AGU Advances publication, will be the study's principal investigator. He works for the National Oceanic and Atmospheric Administration's Pacific Marine Environmental Lab. The study's other authors are He Wang of NOAA's Geophysical Fluid Dynamics Laboratory and the University Corporation of Atmospheric Research, Alistair Adcroft of Princeton University, Joseph Ansong of the University of Ghana, Christopher Hollis of Victoria University of Wellington, Christopher Scotes of the Pale O Map Project, and Range, Arbic, Moore, Johnson, and Titov. Following the initial impact, the tsunami largely radiated to the east and northeast, spilling into the North Atlantic Ocean as well as the southwest via the Central American Seaway, flowing into the South Pacific Ocean. Water moved so swiftly in several directions that it most certainly exceeded 0.4 miles per hour or 0.6 kilometers an hour, a speed that can destroy the fine-grained sediments of the sea floor. According to the team's predictions, the South Atlantic, the North Pacific, the Indian Ocean, and what is now the Mediterranean Sea, among other areas, were largely spread from the tsunami's power. According to their simulations, the water velocity in these regions was below the 0.4 miles per hour cutoff. Although the models did not account for coastal flooding, they did show that the open ocean waves in the Gulf of Mexico would have exceeded 328 feet or 100 meters, and as the tsunami approached the North Atlantic coastal regions and parts of the South America's Pacific coast, waves would have reached heights of more than 32.8 feet or 10 meters. According to Alfio Alessandro Chiarenza, a paleontologist at the University of Vigo who was not involved in the latest study, we have small pieces of the puzzle that keep getting added in. This study is an additional one that adds to the mounting evidence of the catastrophic tsunami that likely covered thousands of miles of ground. What size of the asteroid would destroy the Earth? In the end, according to scientists, an asteroid would need to be roughly 96 kilometers or 60 miles wide in order to completely and totally eradicate life on our planet. Do you think this is true? Will an asteroid ever hit Earth again? Do let us know your thoughts in the comment section below. But that's all for today, so thank you very much for watching and staying tuned. Not sure what to watch next? Well, here are some incredible videos that I think you'll love. To watch the video, either click on the left or the right icon. Thank you so much for joining us. I hope you have a fantastic rest of your week, and I will see you in the next video.